You good? Jim.
Oh, you ready?
Sing the song for a broken hearted.
What is a limit?
Prayer for the faith departed.
Well, a limit, you see, is when a function has a value at a point, you look at the values surrounding that point, and that should give you the limit.
It's my love. Nature will
Left and right limits.
That's my way. I just want to live while I'm alive. It's my life.
Okay, so left and right limits. It's the limit as you approach from the left to the right, usually denoted by a plus or a minus on the limit notation. So if you have a limit of f of x as x approaches a number, you would have a value, so like say 2, and you would put a plus or a minus next to the 2. Now for this piecewise function that we have graphed here, we're going to look for the limit as x approaches 2.
ചിറകില്ലാതുയരത്തിൽ പാറ കനമില്ലാതാടാന്തുടി താളം കൊട്ട വെളിവില്ല കളിയെല്ലാം തീരും കളമെല്ലാം മാറും വിഴിനീരും വായും നല്ലോരല്ല.
Now we don't know what this limit is going to be, so we're going to have to look at the left and the right halves to see if this limit actually even exists in the first place.
സ്വർലോകത്തു പോരന്മാർ
Raise your kappa.
So here is the limit as x approaches 2 from the left side. As you can see, it is 1, because that is where the graph ends up. And for the limit of f of x equals 2 from the right side, as will be corrected in a second, there it is, you can see that it is x equals negative 2. Now, we can see that these aren't actually equal, so we can conclude that the limit of f of x as x approaches 2 is not exist.
Oh my god, I'm 1 damage of lethal.
Now we're going to take a look at the limits using a chart. Now for a chart, what you have to do is look at the values around the value you're trying to look for within the few thousandths place. So in this example, we are trying to look for 3. We look for 2.998, 2.999, and then 3.001 and 3.002. As we draw this graph, you can see that we have a hole at x equals 3. The graph that we're looking at is x plus 3 times x minus 3 over x minus 3. These cancel out, creating a hole in our function. So we fill in these values, which are 5.998, 5.999, 6.001, and 6.002, and we can see that between 5.999 and 6.001, the only logical thing that could be here is 6. So we put that in for the value, and we say that the limit of f of x as x approaches 3 is 6. Yo-yos, God's gift to man. No, but seriously, L'Hôpital rule, or La Hospital, or The Hospital. It's French for something, but we don't actually know what. So we have a function, 5x cubed plus 2x squared plus 3x over 2x squared plus 3x plus 5. And we're trying to find the limit of this function as x approaches 0. For this function, When you plug in 0 into all of the x values,
Thought it was time for an upgrade.
on top, you get 5 times 0 plus 2 times 0 plus 3 times 0 over 2 times 0 plus 3 times 0 plus... Let's just make this 5x. Plus 5 times 0. No, wait. 8 times 0. It's easier. Alright. Now, when you plug these in, the top and the bottom, it equals 0 over 0. And when you have the L'Hopital rule, if your function equals infinity over infinity, or 0 over 0, you take the derivative of the top and bottom separately, and you try to plug in the limit again. A function has a limit at a value if it's differentiable and the left and right limits are the same.
Except it's on the wrong spot.
Heads in the frame.
Is
it 1, 2, 3, 4, 5, 6?
Regret.
What? Do you just want to refill it real fast?
Yeah.
Okay. Now this will be part of bloopers. It'll be great.
Why'd you kill it?
Jim, we have bloopers.
Karn, say something.
Something.
I'm giving up on you.
Say something. I'm giving up on you.
What am I supposed to do? Am I supposed to keep singing?
I'll be the one if you want me to.
I don't know this song.